Hello friends, in today's question, our time dependence of the position of a particle of mass m2 is given as r of t, which is a function of time 2t iota minus 2t square j unit vector. Its angular momentum with respect to the origin at time t is equal to 2 is given as. So we have a particle of mass m and whose position vector is given by rt, and we are supposed to find out its angular momentum with respect to origin. So let us first of all say that angular momentum of the particle with respect to origin, if it is represented as L, then L will be equal to R cross P, where this R is the position vector and P is the linear momentum. And the linear momentum is given as mass into velocity. We can say that linear momentum P is given as m into v, where m is mass of the particle, which is given as 2, and v is the velocity of the particle. Now we have given the position vector, that is r. So it is given to us position vector of the particle is given as r of t, and it is 2t I unit vector minus 3t square j unit vector. So from here we can find out its velocity. So you can say velocity of the particle v of t will be equal to d upon dt, derivative of position vector, and we get d of dt 2ti minus 3t square j. Therefore velocity vector vt will be equal to 2i minus 6tj, and for time t is equal to 2, we are going to find out value of the position vector as well as velocity vector. At t is equal to 2, r of 2 will be equal to 2 into 2 into I minus 3 2 whole square j. Therefore we get r of 2, it means position of the particle at time 2 will be equal to 4i minus this will be 12j. And similarly we can find out its velocity. So you can say velocity at time 2 will be equal to 2i minus 6 into 2j. So we get velocity at 2 is equal to 2i minus 12j. And we already know the formula for the momentum, that is mass into velocity. So we are going to use this formula. You can say linear momentum linear momentum at t is equal to 2. So we get this as P of 2 is equal to mass into velocity at 2. Mass is given as 2 and velocity at 2 is given as, we calculated, 2I minus 12J. So we get momentum at 2 times t is equal to 2. This will be 4I minus 24J. Therefore, angular momentum formula we already know, which is R cross P. We have position vector at t is equal to 2 as well as momentum at t equal to 2. Therefore, you can say that the angular momentum, thus the angular momentum at t is equal to 2 will be L2 is equal to R at 2 cross P at 2. So we know R at 2 is our 4I minus 12J cross P at 2 we already calculated is 4I minus 24J. Therefore, the cross product, you can say L at 2 will be equal to I, J and K, and we have this as 4 minus 12 and 4 minus 24. This will be 0, so it will be coming as I 0 minus 0 minus J 0 minus 0, and this will be plus K unit vector. We have 4 into minus of 24 and minus 4 into minus of 12. Therefore, this will be equal to K unit vector, and we have this as 1696 minus 48, and this will be coming as, this is minus and this will be plus, so this will be coming as minus of 48K. Therefore, angular momentum at 2 is minus 48 and K unit vector. So this is the angular momentum with respect to origin at t is equal to 2. So to check the option available to us, the option number C is the correct option. So we can say option C is correct. Okay, please bear in mind the momentum we are finding in this question is with respect to origin. This completes the question. Thank you.